Your brain contains cells that only activate when you're in one exact spot, and other cells that fire in a perfect hexagonal grid no matter where you go. Neither was discovered until 2005. One of them just earned a Nobel Prize. Here's how strange this actually is. Deep inside your brain sits a structure called the hippocampus, long known to be important for memory. In the 1970s, a neuroscientist named John O'Keefe was recording individual brain cells in rats as they moved around an enclosure. And he noticed something odd. Certain cells stayed completely silent most of the time, then fired intensely the moment the rat entered one specific location, and only that location. Move the rat somewhere else, and a different set of cells would fire instead. O'Keefe called them place cells, and the implication was immediate. Somewhere inside the hippocampus, the brain appeared to be building an internal map, cell by cell, of every location an animal had ever been. That discovery alone would have been remarkable. But it left an open question. Place cells could tell you when you'd arrived somewhere familiar. They couldn't explain how the brain calculated distance, direction, or the space between locations it hadn't mapped yet. That answer didn't arrive until decades later, and it came from a married pair of neuroscientists, May-Britt Moser and Edvard Moser, working at the Norwegian University of Science and Technology. In 2005, while recording from a brain region next to the hippocampus called the entorhinal cortex, they found a second, entirely different type of cell. These cells didn't fire at just one location. They fired at many locations, spaced apart in a pattern so precise that when researchers plotted the firing points on a map of the room, the dots formed a perfect, repeating hexagonal grid, like microscopic graph paper laid invisibly over the entire space. The Mosers called them grid cells. This is where it gets stranger. Grid cells don't seem to care what the room actually looks like. Change the wallpaper, change the lighting, even change the shape of the enclosure, and the same hexagonal firing pattern re-emerges, scaled and rotated to fit the new space. It's as if the brain carries a built-in coordinate system that exists independent of any specific environment, one that can be laid down on top of literally anywhere. Combined with place cells and a handful of other related cell types discovered since, including head direction cells that track which way you're facing, and border cells that detect walls and edges, the brain effectively runs its own internal GPS system, translating the physical world into a private, self-generated map that updates in real time as you move. In 2014, the Mosers shared the Nobel Prize in Physiology or Medicine with O'Keefe. For these discoveries, a rare case of a Nobel being awarded for something almost every person carries around without knowing it exists. The obvious next question is why the brain would evolve something this elaborate just to help you find your way around. Part of the answer is survival. For nearly all of human history, knowing exactly where food, water, shelter, and danger were located wasn't a convenience. It was the difference between living and not living. A brain that could build and consult an accurate internal map without needing to physically retrace every step would have had an enormous advantage over one that couldn't. But researchers have found something else buried in this system that goes beyond simple navigation. The hippocampus, the same structure packed with place cells, is also one of the first regions affected in Alzheimer's disease. Some of the earliest, most subtle symptoms reported by people in the very early stages of the disease aren't memory loss in the way most people imagine it. They're navigational, getting lost on a familiar drive, struggling to find your way out of a building you've been in dozens of times. Long before more obvious symptoms appear, the brain's internal mapping system often starts to falter first, which has led some researchers to explore navigational testing as a potential early screening tool years before a standard memory test would catch anything unusual. This connects to something almost every person has experienced without having a name for it. Anyone who has ever felt disoriented after waking up in an unfamiliar hotel room or felt a genuine physical unease after getting turned around in a new city is experiencing a version of this system working harder than usual, or briefly failing to lock onto a stable map. The discomfort isn't just psychological, It reflects a real physical process, cells across the hippocampus and entorhinal cortex scrambling to rebuild a coordinate system from scratch in an environment they haven't mapped yet. There's also a broader implication that goes past physical space entirely. Some researchers now suspect this same grid-like coordinate system isn't only used for tracking your location in a room. Several studies have found grid cell-like activity patterns showing up when people navigate more abstract kinds of information, sorting through categories, comparing concepts, or organizing memories along a kind of conceptual space rather than a physical one. If that turns out to be broadly true, it would suggest the brain didn't build a separate system for abstract thought. It repurposed the same mapping machinery it already had for moving through the physical world and applied it to navigating ideas, which reframes something people rarely think about consciously. Every time you say you feel lost in an argument or that an idea doesn't fit with what you already know or that you need to get your bearings on a new subject, you may not just be using navigation as a convenient metaphor, you may be describing, in surprisingly literal terms, the same underlying neural hardware at work, whether you're standing in an unfamiliar city or turning an unfamiliar thought over in your mind. None of this means getting lost occasionally is a sign of anything serious on its own. Everyone's internal map glitches sometimes, especially in genuinely unfamiliar places. And that's normal. Expected behavior for a system doing exactly what it evolved to do under difficult conditions. But it does mean that the sense of direction most people take for granted, the quiet, automatic feeling of knowing roughly where you are and how to get back, is running on some of the most intricate, precisely tuned circuitry the brain has. It took until 2005 to even discover the grid existed. It's been running quietly in the background of every walk, every commute, and possibly every complicated thought you've ever had the entire time.